Just before we move into exercise 14D, I want to talk to you about one other advantage of knowing how to sketch a trig function, and that is you can often sketch a trig function to help you to solve particular trig equations. Now, these trig equations are fairly unique. They consist of a combination of trig and some other sort of function. So the different functions we've looked at are what we would just call polynomials, x to a power. We've looked at log of x as a different function. We've looked at the exponential e to the x. So if you find, as is the case here, that you're asked to solve sine of x is equal to x squared minus 1, you can see that we've got a combination of different types of functions. Now that's fairly unique. I'll just clarify that rarely does it say solve this. The wording of the questions that involve this sort of equation are, the question might ask you for the number of solutions. So it doesn't actually want the value of the solutions, but the number of solutions. So, that lends itself really nicely to graphing these two equations. So we would graph y equals sine of x, which we know just goes like this, up as high as 1. And x squared, if we graph x squared minus 1, then we know that it is a parabola pushed down here. It's going to cut at minus 1, and it, whoops. And you could see there that there would be two possible solutions there and there. Where do these two graphs, the graph of sine x and the graph of x squared minus 1, where do they intersect? Would give you the solution to solving this, but the question often doesn't say that. It just says how many solutions. So you're just looking for the number of places that these two intersect. So the answer would be 2. It could say find the approximate solution value. So you might see that in a question. And at that state, you are approximating what that value is and that value. And obviously we'd need more details on this graph to be able to approximate what these x values actually are. So just keep in mind that when you see a question that says find the number of solutions, or find approximate values, then drawing the equations, drawing the graphs of the functions is a good idea. Just one more thing, I guess this could have been presented as sine of x minus x squared plus 1 is equal to 0. Now, again, you would need to look at that and recognise that it's a combination of different types of functions. This is a trig function. This is what I'll call a polynomial function because it's x is its base and it's to a power. Okay, let's move on. In exercise 4D, we're going to learn some identities about compound angles. Now, compound angles is when we've got more than just an x, more than sine of x or cos of x or tan of x. And we're going to learn these identities. Well, in fact, these identities, these 3, are given on the reference sheet, so you don't need to learn them. But just let's get an understanding. What is it that makes it a compound angle? And a bit of a, let's have a look at what the right hand side and the left hand side actually are. So the first one is sine of theta plus, and I'm not very good with my Greek letters, I think it's psi, is it? I like to think of them as sine alpha plus beta. No one says we have to call the angles by those particular Greek letters. We could use alpha and beta that we're a whole lot more familiar with. So the equivalent using alpha and beta would be sine alpha cos beta plus cos alpha sine beta. Okay, so what is that? This is a compound angle because it's more than one angle or more than one thing happening to the angle. We've got the sum of angles. So it's saying that the sum of angles is equal to the product of sine and sine of one cos of the other plus cos of the first one, sine of the second one. With most of these, we're just going to be learning the identities and seeing where we can use the identities. There's not a lot of application even in this whole Extension 1 course of these identities, apart from in a proof or a show question. However, we do need them to be able to integrate some trig functions. So if anything, their real, I guess, sort of application for you in this course, you will see when we're integrating trig functions. But for now, and in this course, we're just playing and learning these identities. So you're developing your skills. This is just a skills exercise. The other one is cos, and if I was writing that as cos alpha plus beta, so we're talking about the sum of two sized angles, then it is the cos of alpha, cos of beta, minus sine of alpha, sine of beta. Tan of alpha plus beta is tan alpha plus tan beta, all over 1 minus the product, tan alpha, tan beta. So you can imagine there's all sorts of proofs and show questions that could be made up where you've got to substitute, for example, sine alpha plus beta with this, or don't forget the reverse. You may come across this given somewhere and you can substitute it for that. Okay, the ones that aren't given are when we've got the subtraction of the angles. Let's have a look and see if we can see some things that are some pattern that's going on and will be given on the reference sheet, and see how we can adapt that then to the minus. I think it's pretty obvious. We've got sine of alpha plus beta and there's a plus sign here. So let's highlight the things that are the same. And we see that same pattern occur over here when it's a subtraction. So we've got subtraction, we've got subtraction. Now, what can we take from what's on the reference sheet and apply it here in the subtraction of the two angles? Well, on the formula sheet, you've got that it's sine alpha cos beta, and what happens over here? Sine alpha cos beta. And here it was cos of alpha sine beta and cos of alpha sine beta. What you will often see, and just the way that they test this sort of thing, is, for example, you could be asked about getting exact values, for example, of sine 60 plus, say, 45. So sine 105. Let's say the question was, find the exact value for the sine of 105. Now, you might go to your calculator and it's not going to give you the exact value. So what you do with this sort of question is you say, well, sine of 105 is the same as the sine of, 60 plus 45? And then you can break that 60 plus 45 up into sine 60, which you know the exact value for, cos 45, which you know exact value for from your triangles, plus, and so on, cos 60 sine 45. So that's the type of application. We're just learning these identities and using them just in a format to perfect these skills. Not real application, just perfecting the skills. Now if we go on and look at the cos alpha plus beta as it's given on the reference sheet, let's see what's going on there. With the cos, it's not so nice. We've got a plus and a minus. Let's see what's going on over here. We've got a minus and a plus. So it's the reverse of what happens here. And I guess that was the same with the sine. This, when we were adding the compound angles, then over here we're subtracting, then we end up with a subtraction. So it is just a matter of, this is what's on the reference sheet and how do I adapt it for the subtraction. And this time with cos, we're taking the cos of both the angles to start with and subtracting the sine of the two angles after that. And then obviously when it's a subtraction, we still take the cos of the two angles, but this time add the sine. Tan, I'm sure you can see the patterns occurring there. When we're adding the two angles, we have a plus and a minus. When we're subtracting, we have a minus and a plus. I think I've touched on this. It's important to study and recognise the reverse of these expansions. There'll be times when you need to replace, say, sine alpha cos beta minus cos alpha sine beta with, you have to be able to recognise that as being this and replace it all up with sine alpha minus beta. You've heard me often say that a lot of the maths questions will require you to make connections to the skills you've learned, the rules you've learned, the formulas you know. Then these sorts of questions also require you to make connections back to these identities. And it's not a matter of good luck as to whether you could make that connection. Making that connection very much depends on how well you've committed these things to your memory, that you can access them easily and quickly because you know them. If you don't commit to learning them, you will struggle with making that connection to them. Just because they're on the reference sheet, that's no guarantee that you will be able to make the connection. I really will have to stop the video there or I'll run out of time on it. I'll do the examples in another video.